Hi everyone, in that video I will explain you the graph from the homework. So on the first graph we have, this one will be for a of t in function of t as function of t. This one will be for v of t as function of t. And the last one will be s of t, so the position of the car from t. So for a of t, the first equations looks like minus at plus b. Okay, I don't do it with special data, just like something like this. Okay, so the first equation, the first part until t1. Okay, so we will have the first segment from 0 to t1 for the 3 curve. So the first part is a of t equal minus at plus b. And it goes up to a equals 0 when the velocity is constant. Okay, so I mean that your first acceleration will be a line with a decreasing slope of minus a, that's the slope, okay? And it starts from b and it goes to 0, okay? The second segment, we know that from 0 to t2, the t2, the acceleration is 0, okay? Because the velocity is constant. And from t2 to t3, we learn that the acceleration is negative. Let's call that minus c, okay? So that's the graph that we have for the acceleration. Now, how do we go from the graph from acceleration to the graph of v of t? What do we see? We see that the acceleration is positive. If the acceleration is positive, it means the velocity will increase. If the acceleration is 0, the velocity will be constant. If the acceleration is negative, the velocity will decrease. Now, what is the shape? So the first equation of the acceleration is minus at plus b. So if I take this acceleration, it means that v of t will look like minus at squared divided by 2 plus bt plus a v0, but we start from 0. So this one is a parabola. Is it a parabola with the 2 legs up or 2 legs down? Because of the minus, that's the 2 legs down. Are we in the part that increase or decrease? We are in the part that increase because the acceleration is positive. So we will have something like this. Oops. Parabola until t1. Okay. After that, we say that v is constant, so that will be straight. And for the third segment, we have the acceleration that is equal minus c. So if we can take minus c, that will give us v of t equal minus ct plus the v1, the initial velocity, but that's the initial velocity from t2, from there. So that's just a line, and that decreases until t equals 0. So this is for the velocity. And now for s of t. So we see the velocity is positive everywhere, everywhere. So globally, the distance will increase, and increase. It will never decrease. It will keep going. That just means that the car is keep going on, keep moving forward. Okay. So the first equation v of t was a parabola. So now I take the integration of v of t, and I have s of t equal minus at cubed divided by 6 plus bt squared. The v0 that was 0 at this point, and s0 that will be 0. So it looks like this equation. If you plot this function in your calculator, it will look like this. So this is 0, 0, like this. So we are after t equals 0, of course. So on that side, and that will increase, so we are in that portion of the curve. So something like, it should be a cube. It's not that easy to draw. Let's try to make it like this. Okay, and you can check in your calculator exactly up to t1 if we stop at that point or at that point. We are not sure. After that, the velocity is constant. So when the velocity is constant, so let's say the velocity equal d, a constant, the s of t will be equal to dt plus s1. So that will be from this s1, and that will be a line, and that will increase up to s2 at t2. The last one, v of t, was minus ct plus v1. So if we take the integration of this one, that gives us minus c t squared divided by 2 plus the v1t plus the position there. Let's call that S2. So this is also a parabola with the legs down, but we are increasing. Are we now in that part or that part? It depends of your t, but it's increasing. So somewhere, something there. It should be a little bit round. Okay. We should have a continuity, but like, I mean, that's the same point, but we may have a little, it doesn't have to be smooth. And that's at 3, the final distance at your T3. So this is the steps to find, to draw your graph. What you have to remember is when acceleration is positive, velocity increase. The acceleration negative, velocity decrease. When the velocity is positive, distance increase. If the velocity was negative, it doesn't appear there, it means the distance decrease, it means the car is coming back, moving backwards. And you can find the shape. You can find the exact functions and plot them in your calculator to help you see the exact shape. Hope that helps. Bye-bye.